Welcome to the third episode of AI for Absolute Beginners. Today we're going to learn about overfitting and underfitting. I'm sure you have heard about this somewhere. Simply speaking, overfitting is too good to be true, and underfitting is too bad to be true. So what it means is, on the last episode, we talked about data can be separated into three different ways. One is training, validation, and test data. For example, let's say I'm an AI model. I learned from this book. It's training data, but I studied so hard that I only know how to say what is right and wrong based on this data. So I'm just like too detail-oriented model. So when I actually apply this model to other data, such as validation data, suddenly my AI model performance drops. So it means in the case the result from the training data is so much better than the validation data. It means I am too complicated, I'm thinking too much, that it is too good to be true. But on the opposite, the underfitting means I didn't learn that much well. Let's say I have such a small training data set that I can't learn things properly. I'm just randomly predicting based on the small data set that we have. I don't think too much. I'm just too simply thinking that if I apply to validation data, test data, I'm not performing well. So the sign of the machine learning engineer can identify if I'm too good to be true or too bad to be true is by looking at the different experiment result, what we call the evaluation metrics performance on the training data, validation data, and the test data. So why do we have this overfitting and underfitting terminology? Because developing AI model and measuring its performance is trying to find the fine line between too good and too bad. Because this model, some will say, oh, wouldn't it be better if it's just too good? No, because AI model, if it needs to be applied in the real practice, it needs to be resilient. It needs to be robust enough that you can apply in the real world. That's why we need to find the balance between too good and too bad. So what can we do if it's overfitted or it is underfit? Let's say my model is overfitted. My training result is so much better than validation result. It means we need to put stop. We need to put limit on the learning. Just stop here and stop learning the details of the pattern. One of the things we can apply is called regularization. And on the other hand, about the underfitting, which is likely to happen because model is too simply designed, or it has too much regularization, too much limit in the learning, or too less data that we can learn from. The measure of overcoming the underfitting would be giving more complexity in the data. You can add some extra layers on the model architecture or give more data that the model can understand what is happening. So today we learned about the very essential topics, the overfitting and the underfitting. I feel like when you're developing model, it's like trying to deal with really tricky baby. You need to guide them to the right way, keep an eye on if it's going too good or too bad. If this was helpful, subscribe and follow on additional series about the AI for absolute beginners.